Hello, I am Alejandro Medellín Junior Pérez, and I'm going to talk to you about my SolidWorks certification. This was my project in this course. And yeah, basically I took some courses in SolidWorks and then a certification exam. So let's go. So as I told you, I took a SolidWorks exam, which SolidWorks is a CAD tool. CAD stands for Computer Aided Design. It's made by Dassault Systems, which is a French branch that has many different softwares similar to CAD and SolidWorks, but SolidWorks is one of the best ones of them. So there were 3 courses: the basic course of SolidWorks, which taught us how to use the tools and how to draw and everything. Then the simulations course, which, as its name says it, taught us how to do simulations inside the software. And the third one is the additive manufacturing course. This course taught us how does the 3D printing world works, different types of 3D printing, and the different types of materials, mainly plastic, but there are many kinds of plastics. So that's what they taught us there. So for this project, we had 3 main objectives. Obviously, the first one was to complete the 3 courses. Those were shared in the IntelliJ platform, and it was delivered by some videos. And after you watch those videos, they give you a certificate that tells that you have finished those courses. We also had to take a CSWA exam. CSWA stands for Certified SolidWorks Associate, and this exam mainly was about mechanical design, where we were asked to draw parts, do assemblies, add materials, see what was the mass of them. That was mainly the exam. It was composed of 14 questions, and we needed to get that in order to get our final certification. And last but not least, our objective was to have a better understanding of the SolidWorks environment, because the university teaches how to draw in the computer. But they taught us in CATIA, which is a similar software also by Dassault Systems, but SolidWorks is more complete. So it was important to have this software because it is widely used in the industries, since it has many components that help to design, to make prototypes, to simulate. It even has electrical designs, and the CAM, which is computer aided manufacturing. So it's widely used in today's industry. Next, we have the goals we wanted to achieve. So we had 4 goals to achieve this in this project. The first one was obviously to understand the tools in the software, because it has many tools that help you to do the design, the simulation, everything we've been talking about. Also, how to make proper assemblies, because when you have a complex object composed of many parts, you need to assemble them into one object. So you need to put constraints and make them so they can move and they don't like move in positions you don't want to. That's where assemblies come important. Also, we wanted to understand how the corresponding simulations work, because if you want to implement the object or the part you made in SolidWorks, you want to see how it will perform when some internal forces or external forces act on them. So that's where the simulation part is really important, because it allows you to know where are the weak parts of the object, where you need to put a little bit more of material maybe, or change the form of the object in order for it to withstand that amount of forces, etc. And finally, understand how the additive manufacturing works, which, as I told you, is about mainly the 3D printing, and how it helps to how the different types of 3D printing will help in different kinds of parts of the model. So the specifications, as I told you, there were 3 main courses: the basic course in SolidWorks, simulation course, and the additive manufacturing course. There were videos for the basic course. It was 41 videos, making a total of 6 hours. There were theoretical and practical videos where you needed to do the designs. Then the simulation course was 28 videos. It was a length of 5 hours. It was mainly theoretical and analysis about the simulations, as you can see in that picture. And finally, the additive manufacturing course, it was composed of 10 videos, and the length was 4 hours. As I told you there was more theoretical, just how everything works, different kinds of materials, how they perform in different kinds of 3D printing techniques, etc. So how does the development of the design works? You are given a plan, like a blueprint with the requirements. As you can see there, you have like the different measurements that the part needs to have. Then you go to the designing the software. As you can see there, there's the same piece drawn in SolidWorks. It also says there like the mass and the different physical properties, given the material that you give the piece. Normally the plans give you the material they want to have. And then once you have the piece, you pass to the simulation in the software. As you can see there, it's a different part, but there is a simulation to see how it will perform. This example was that a car motor was placed on top. So you see how it moves and pans, like because of the weight of the motor. And finally, once you have everything perfectly designed, you pass to the 3D printed design. As you can see here, it was a 3D printed motor, a monoblock. So there you have like the different kinds of plastics, depending on what the function of the piece would be, etc. So it's pretty, it helps a lot for the prototyping and making it not that expensive to have different prototypes, comparing it if it was used a CNC, which is a bigger machine and it uses metal. So it's better to have a 3D printed prototype. As our results, here are the 3 certificates I talked about. The first one is the design. The middle one is the simulation course, and the third one is the additive manufacturing course. As you can see, it says that I obtained them, and it says the different lengths of the courses over there. And the evaluation, as I told you, I needed to take an exam, the CSWA. So here I had got 125 out of 130 questions correct. So that means I passed the exam, and they gave me this certificate from Dassault Systems. As you can see, it's for mechanical design, and it was made in SolidWorks, as it says on the top right corner. So in conclusion, SolidWorks is a powerful tool that allows us to make the complete process of developing a mechatronic project, because it helps with the prototyping, with the design, with the simulation. But it is also important to know the different types of manufacturing in order to make these prototypes so that they are better and we got better prototypes so that the final product is the best we can have. So it is important also to know that the different types of material, the different types of manufacturing and everything else. And it is important also to understand what our object will be doing so that we can make the proper simulation of it. Thank you for your attention, and that's it. Thank you.